from the last class, what I had you guys do was put this in a box. So I'm going to use a bright color for this conversation. I'll make it a little thicker just so you can observe. I had you draw the line to follow the grid. Using a ruler, draw the line. The grid will take care of itself. And then what you have left, what little bit is left, you can go ahead and erase. The same action is occurring to the second part. You got to follow the lines. So these two objects, put them inside their boxes. This reflects the conversation I had before when I talked about the cube.
This is the glass box method, right?
You got it. Exactly. This is that respect the cube business I was discussing where I said this is the front, this will be the right side, and this is the top all the time. Whether it's first angle or third angle projection is irrelevant. That's why I'm having you put it in a box. Because no matter what, this is the front. No matter what, this is the front. This is the right side view, and straight down is the top. Straight down is the top. That's number one. What I want to show you next is how to form your views with this in mind. So I jumped in product that allows me to use a virtual ruler. That's called OneNote. And I've got my ruler. Do you all see the ruler? If I take my ruler and line it up, and then here we go here, and then wherever these two intersect, put it in a box. Think of it as the glass box. That's correct. And then we can turn around and just, again, the cube, respecting the cube. We have to talk about how you're going to orient this on a piece of paper. The first drawing is going to be third angle projection. For the purpose of this project, you're going to actually use grid paper. This first time, I'm going to print it. I'm going to show you how I'm printing it. Remember, the most important thing is how do you want to print? Fit printable area or actual size?
Actual size.
Actual size. Got it, guys? You always print actual size. When we look at the paper, you don't want it to print miniature. You want it to be full size 1:1 scale because every square on this is what you're concerned about, the size of these squares. Technically, the size of these squares, each one is 1/4 inch. For the purpose of this drawing work that we're doing, the reason I'm saying that is because if you print this the wrong way, it's going to shrink it, and it's not going to be 1/4 inch, it's going to be less than 1/4 inch. You have the nice big size view of that drawing in front of you. I got this tiny little postage stamp in the corner. Got it, guys? I'm going to maximize this postage stamp so I can talk about what you're doing with this postage stamp, which you have as a nice big drawing. So I'm making it really big so I can discuss just this image and not confuse you. What you're doing when you have this layout, you see that there's a box laying on top in this grid. I'm going to create a checker box. Do you see this? And then there's another one. And there's one in between. I'm doing alternating squares so you could see what I'm trying to show you. If you look at your grid, you're going to see that it's made up of a bunch of squares that happen to be going at an angle. Do you see the checker box now? If you can already see these squares, that's great. Not everybody can, so that's why I'm taking this real slow. I'm going to color each of these so that you have a visual of what the top of this thing looks like. If I had a checker box top, if this doesn't make sense to you, I understand. This is not something that jumps out at you visually that easy. I don't expect you to get this overnight. Now it pops at you, doesn't it? And you see that square right on top, all the little squares. That is what this top is made of. I did them alternating colors so that you could see that. Each square is going to be an incremental distance. Each square, do you see how I'm putting the dashes back here? The complementary dash goes to the front. Complementary dash to the front. See that? So you can actually break your grid up. You can do that like with your eyes that way, or you can go ahead and incorporate a ruler. That way you can assess how many squares, left to right, front to back, make up this object. Picture it as square footage. You know how when you think about square feet of a room? Square feet, yeah? Well, this is going to be like square inches. We're going to make a statement that every square on this grid equals 1/4 inch. This is the scale we're going to use. We're going to say that 1 square equals 1/4 inch. And 1 square will be, of course, in both directions. So it'll be a 1/4 inch this way and a 1/4 inch this way. So that's what the value of one square in both directions. 1/4 inch one way, a 1/4 inch the other way. That's going to be our scale that we're using for this drawing. That is the same scale we're going to use for the other part. Now that we know what scale we're using and we have an idea of the orientation, now we just have to figure out what's the top, what belongs to the top view, what belongs to the front view. When you're doing this for the first time, I recommend you do it in stages, not all at once. My first advice is you never start on the edge of the paper. You don't start drawing on the edges of papers. So that's a no-go. You always want to draw with respect to what you are doing completely. You know, like, am I putting dimensions in? The answer today is no. You're not putting any dimensions in this drawing. You are literally drawing just to draw something using a specific unit of measurement. You're not going to dimension what you're drawing. We just want to get it on the paper. We're going to use third angle projection, which we know means what? When we think about third angle projection, what does that mean? I'm going to draw the little sketch in the corner. Third angle projections is in what quadrant? It's in the third quadrant. So the images that are in the third quadrant, but this is right out of geometry, first, second, third, fourth quadrants. Remember those? Mm-hmm. In the third quadrant, the front view is here. The right side view is here. The top view is here. This is in the third quadrant, hence why it's called third angle projection. First angle projection's up here, the rest of the planet. Remember that. So get accustomed to that reality. And that means the front view can still stay in the same spot, but the top view goes down here and the right side view goes there. It's just a function of where the views are physically located. Extrapolating more information on the front view, right view, top view, if I just look at this little picture, what I usually say when we put a drawing on a piece of paper is something called fill D page. Fill D page. Somebody's name, right? It's also a play on the actual words fill the page. This is how I was taught, Mr. Markison. Of all things, it was my commercial art teacher who taught me about fill D page. You want your work to fill the page. You want it to look neat and not scrunched. You don't want it stuck in a corner, and you don't want to run out of space to put your dimensions later. Ultimately, you're going to strategize on scale and all this other stuff, but for today, I just want you to think of one basic thing. It's at least balancing the drawing. It's the easiest way to balance, any drawing, identify where the center is. You have this marked in your paper anyways. That's the dead center of the paper. You notice that? Draw it lightly, just gently score it with your pencil. Here's a small problem. Is it really centered in the drawing area? No. It's centered to the paper, which is fine on the vertical, but not so good on the horizontal. So where do we really want this centered? Inside this space, not that. If you're going to ask me, well, Ms. Sherrison, why did they put the arrows there? Because the arrows are set to the grid of the whole paper. I can disagree with the maker of this grid, but I'm not going to. So what we have to appreciate, at least for our type of drawing, is we want to be centered in this space. So what is this distance? Take a ruler to it. The height from this top piece to this bottom piece. So the total height is 7 1/4. So what's half of 7 1/4? So 7.25 divided by 2, that's what? 3 times 2 is 6. That's 12. What's 12 divided by 2 is? 6. Okay, that's 12. And then there's 5. 3. 2 times what equals 5? You got to go with the 2. So that way you get 4. Then you got a remainder. 10. This is why math is a major component of everything we do. If you're laying out a piece of metal, laying out sheet metal for cutting, for building something, I don't care, or laying out a job that you're going to be CADing up, putting on a computer, and then you're going to send it to a laser, doesn't matter. It all requires a little bit of math. So please don't forget the math. Okay, so how many squares? We need to be at, what was the answer? I erased it already.
3.625.
3.625. So where is that? Can you guys tell me about where that is? 1, 2, 3, 4, 5. What, 4 was, that's 3, that's 1. 1, 2, 3, 4, that's 2. 1, 2, 3, 4, that's 3. 3 and 5/8, correct? 625 is 5/8, so that's about there. And that's my halfway mark on my piece of paper. And then this way is easy because I got the 2 arrows to line up to. You see that? I've broken up my sheet of paper in 4 segments. My front view will go here. My right side view will go here. And my top view will go here. You want to balance your work. So I've got my ruler, just like you have yours. I have my piece of paper. I gently marked off my spots. Where will I start my front view? If I look over this front piece, the top of the box is this thing up here. And the right side view, that's the right side view. So when I look at the front of this object, this front right here, I see this. I see this ending down here. Do you see that? And then I see this here is where it actually ends. And then this goes at an angle this way. And then I can carry this line through. This line predates everything. You had this line before. So you have these existing lines, but you realize where they end is not where you thought they did. Like this ends all the way over here, but that does not exist. That's hard to see, isn't it? What is the easiest view for you to look at? I'm going to ask you that question. You guys vote. Top view, front view, right view. Which view looks the easiest for you to tackle first?
I was thinking the top view.
Top view? So then the next question is how or where should I begin? My advice is the following. An inch into the drawing would be ideal. An inch into your which is right 4 squares in and 4 squares up, where you should consider the exterior edges of your views. Why did I pick 4 squares? Because it's an inch. The general rule of thumb is you start your stuff an inch inside your border. That's the general rule of thumb when you frame a view. Generally speaking, you're going inch by inch into the... Now that I'm in to my frame, now I can start talking about the views. We're going to start with the top view, and we're going to notice this entire shape, but with respect to the full length of it. We know that it ends here. Why? Because remember how in our past project, they gave us those little tickies to use as a guide? They were in this thing too. So use them. That's the full length of that part. The back wall, that's right here. That's the full length. So how many squares down is this? 1, 2, 3, 4, 5, 6, 7, 8. Did you guys get 8 as well? What's 8 squares, guys? 2 inches? So that's the bottom perimeter of this piece. 1, 2, 3, 4, 5, 6, 7, 8. See that? So I can draw that line across. Now the full length. What is this full length? 1, 2, 3, 4, 5, 6, 7, 8. So at the 8-inch mark is this line. Remember that. At not 8-inch, at the 8 square, at the 2-inch mark. Because the units of measurement, right? And it's another 1, 2, 3, 4, 5. Is that 6? Or 1 second. 1, 2, 3, 4, 5, 6 squares. So 1, 2, 3, 4, 5, 6, 7, 8 squares. And then another 1, 2, 3, 4, 5, 6 squares. So at this mark, we have this, but how many squares over does it go? 1, 2, 3, correct. So it actually ends here. It ends there. That's where that line should end. Where does this line end? Can we even tell? Not really. It ends somewhere in there. But what do we see here? How far does this go? 1, 2, 3, 4, 5 squares. Is that correct? You see it better than I do. 1, 2, 3, 4, 5. What was it? 6? What was it? 5 or 6? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So watch this, guys. Where this ends and that ends, that's where this line goes. The unknown position is where these two connect in the top view. only in the top view. We're not talking about the other views. We're only talking about the top view. So you will have this basic shape. And why was my line longer than it needed to be? Because I didn't know the position. Remember that?
Mhm.
1, 2, 3, 4, 5. See, that's 1, 2, 3, 4, 5. That's that position. So what's missing, of course, are the two circles. Now the question is, how do we locate those two circles? Count the squares, right?
Mhm.
That's exactly how you know. So let's start with the one in the lower left corner. That's 3 squares up and 2 squares over is where the center of this is. 3 squares up and 2 squares over. So what did I draw there?
The center line.
A center line, because we talked about center lines already. So you know that's why you want to put a center line there. Not another kind of line type. You want to draw a center line. Ta-da! See that? That position where my first circle will be. Now for the next one, it's 2 squares over, and how many squares? 2 by 2? Is it 2 squares by 2 squares, guys? So this center's over here. Now how to draw a circle. If I was on a piece of paper, to be honest, I would actually take my thumb and my pencil. My thumb and my pencil. I can't show you this online, I'm sorry.
That's all right.
The thumb and the pencil. I put my thumb in the center. I put my thumb in the center. I put my pencil where I want it to be, and then I would just go around. Exactly. Makeshift compass. A makeshift compass. If you are using tech, like I am, you go to shape, find circle, and then you fiddle with circle. I say you fiddle with it because it's not that perfect. You see that? Because then you got to position it where you really want it. And then you got to keep messing with it until it's the right size. Because if you're anything like me, you want to be really picky about where you put it. That's as close as it's going to get. And then if you're lazy like me, yeah, that got recorded. You're right. Once you find what you like, you copy and you paste. Oh, there it is. I was like, where did it go? There it went. Whee! And you drop it. You drop that puppy in. 1, 2, 3 squares up. 1, 2, 2 squares over. That's how this center was defined. Cool? Yes, that's a very good question, and that's a question we're going to ask the client. Since I'm the client, my answer is yes. But you are right to question that, because that is actually a very important thing. Is this correctly positioned? Do the holes go all the way through? So notice we've got the top view. What we're missing is this little object back here. See this piece in the back? Well, it's not in the back, but it's set back. This entire piece here. When you look at that piece, where is that? Where is that inside the part? If I zoom in here, where is that? I'm going to draw it as if it's hidden lines. Why? Because it is. You see that object? See that?
Mm-hmm.
So how far in does it go?
Well, wouldn't it go as the same as the end piece on the top?
So it would go in, you're thinking it goes in here?
I'm not sure.
Good question. Right. Actually, it's 1 square in. The reason we know it's 1 square in is because that's what it is here. See that? It's 1 square in and 3 squares up. But we're in the top view, so we only care about how many squares it's in the top view. And that's right here. It is a hidden line, though. So it's supposed to be thin. Now, what problem do I have that I've not accounted for yet in my drawing? What have I not accounted for? What should I have done? I should make my object line thicker, make my object lines thicker. With a pencil, this is actually easier than with this pen system that I'm using right here. And by the way, this is the future of drafting. Keep trying to explain to people this is the direction we're going in. AutoCAD hasn't figured it out yet. They keep wanting to have us use a keyboard. I keep messing around with their tablet version. Still doesn't work like a tablet. This is what I mean when I say tablet. You see how I'm digitally drawing right on the paper, on the virtual paper? This is where they need to be going. Maybe they'll figure it out, but not today. Now, do you notice how the object lines pop out, whereas the lines that are supposed to be hidden lines do not? I didn't make them extremely different from each other, but I did make them a little different from each other. Do you guys see it? I hope, to some degree. Sorta. Let me get closer. Let me get closer. Let me get really close. Now do you see it? Now I can erase this like tiny little bits, can't I? Oh, seriously? Come on. Let me erase just a little bit. Oh, look at that. Not quite there yet. Okay. So there's our top view. Actually completed. of all things. The top view was the win. Who said top view? I think one of you over here
I did.
mentioned. Oh, you did. There you go. Top view was the best one to start with. You were able to get the most information to build that top view. Now the question is how to do the front view or the right side view. So the first thing I do, because I'm lazy, remember how we did with the first drawings? When I have a view done, I want to create the next view. Remember that? What did I do? Carry the lines down, I used to tell you. That's exactly what you're going to do here. You're going to carry your lines down. See that? You're going to carry your lines down. And this now becomes an object line down here. Now here, when I look at the vertical, how tall is this thing? I'm looking from here to here. So that's 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6. So it's 6 squares tall. 1, 2, 3, 4, 5, 6. Now, we know that it stops here. So we know this is an end. So we know this thing ends here. And this piece is up how many squares? 1, 2, 3. So we know this is 3 squares up. Where these two meet, X marks the spot. This X here and this X here marks the spot where this angled line belongs. Whether you see it or not, that's what the drawing tells you to do. Because of where the lines fall. I know this object ends here. And I know this object ends here. That's it. So if this object ends here and this object ends here, then what's left? An angled line. I'm going to change colors on it to emphasize what I'm talking about. This angled line is this angled face. That is this face. That is this face. I know you don't believe it, and that's okay. What tells you that's what it looks like is because this ends here and this ends here. Where these two end is why that angled line looks like that. It's just the leftover. There's nothing there. This ended here. Okay, because that's where the lines came down from the top view. This is 3 tall because that's what it is in the image. So the remaining shape, that light blue line, is a product. This is the end of this here. This ends here. That's a given. That's how it's determined that that's where it goes. Those lines carried down, and that's how that became what you see there. This ledge is 3 squares up. So that's up here. The only question is, where does it end? It ends wherever this is. And this isn't necessarily attached to a specific spot. Do you see that? It's not aligned perfectly with a line. It's a little off, in fact. But that's where it ends. It's not perfectly aligned with a grid. It's next to a grid, but not perfectly aligned with one. This one is. Now, is that real? Is there a line that's down here? Do you see a line somewhere in here? No. So this isn't a line, but this is where this ends. Remember how when you had that one drawing where I told you the jaw line? Remember I used the term the jaw line, that last drawing that you guys had to do it to fill in? Mm-hmm. And I said you have to picture it at a jaw line because it was that curved object that had...
like a lip, right?
The lip, right? It had this in it. Remember? I said that was a jaw because that was a round circle connecting with a straight edge. So wherever those 2 points met, that's why this went that high. Remember that? That's what's going on here. Same concept. It's just not with something that's round. It's something that's cutting in and then disappears. See, so there's nothing there. But what it does do, it does have a finished line down below it. It finishes here. And you see how that's a weird angle? I told you it wasn't a specific angle. It's just an angle. Just connects the 2 parts together. That's all it does here. So now that's how that view gets formed. Now the only thing missing are the hidden lines. So I'm going to switch over to a very thin line type to drop in the hidden lines, which are going to be annoyingly close to each other. They're annoyingly close to each other. If the hidden line and the object line are literally on top of each other, you don't draw a hidden line. You only draw the hidden line where you can see it. Remember, hidden lines are just dashes. And don't forget the center lines, because the center lines tell us that there's something round in there. If you don't have a center line, then we don't know that it's actually round object going into it. It could be a rectangular box for all you and I know. So it's true. These two are very close to each other right here. But that's what this view would look like. Now comes the tough view. So the top view, the front view, the right side view. Now that you have two views, how would you figure out your side view, your right side view? What's the method I should follow?
You're going to draw the lines and do the
45 method?
Yeah.
Is that what you were thinking? Now here's what's different. If you have the if you have the 45 triangle already available to you, which you might, who's got their drafting supplies, you've got this already. Because all you really need to do is, what did I say, 4 squares in? That's going to be your outer perimeter, 4 squares. And you're identifying the bottom of your part off of this view. So your next order of business is to get your 45 triangle out and go to that intersection and just draw an angled line, 45 degrees. So the box with those 2 lines is where you're identifying is your perimeter. Not expecting you to get it exactly as I'm doing it. So that's why I'm recording this, so that you can slowly go through it yourself. I'm going to pick, what do you think, green? What color do you think will stand out? What color? Green might not stand out so well up there. I'll try red. You're lining your objects up. And on this side, of course, if it's an object that you know is going to be hidden, you draw it as hidden lines, not as solid lines. This object right here denotes the end of the part. The end of this piece, the 3 by 3 square. And you know that's here. So that's this thick line here and here, which is these 2 lines right there. The back side is this back side. That's there. That's this piece. That's the whole height. The little hidden objects, I'll switch back to red. So the holes, you see where they're going across. See that? Bring these down. These 2 are together. That's a hidden line. This is a hidden line. This is a hidden line. In the center of these are what? Center lines. Then you can clean it up. There's one thing that you can't see. This intersection, where does it fall into this drawing? What's the best way to get it? Line up your ruler to where it ends, right here. This position, and carry that straight down. You see it's not aligned with any particular grid. You notice that? It's off. It's in its own spot. But that position right there, that's the spot that connects with this spot right there. That represents this line in true position, and that's your drawing. This view is your first view. From this view, you'll get your front view, because everything is carried down to get you these dimensions. Get it? The toughest view demands that these 2 views be done. So that way you could carry your lines across to get that information. That is how the views are developed. Ultimately, you must have this, your 45-degree line. This is mission critical to making this view, the right side view, possible. If you choose to ignore the need for that 45 angle and just try to eyeball it, or you're going to take the method that I've had some students do, I can measure it, I'll figure it out that way, you're going to have a hard time. I can draw faster using this miter method with this 45-degree line any day of the week than sitting there and transferring dimensions from one view to the other. It is not a simple method as far as just drawing itself. The miter method is tried and true, but just getting used to drawing, seeing the views, I understand how difficult that can be. This will end this video.